All right, this is the OFI testing equipment permeability plugging tester, or the OFI testing equipment permeability plugging apparatus, or PPT or PPA. It really doesn't matter what you call it, but basically this is an adaptation of the modification of the standard HTHP filter press, where you filter up with the PPT. I've covered all of that in part 1, the introduction. So here in part 2, I want to cover the initial setup and assembly in order to prepare ourselves for the test. So the first thing we do is we ensure that all valves are closed and the regulators are all backed out. This is the inlet hydraulic line from the hydraulic pump. So to close that valve, I move the handle 90 degrees or perpendicular to the flow line. On the back pressure receiver CO2 pressuring assembly, I make sure that my regulator T-screw is backed out all the way. That way I can't add pressure when the CO2 bulb hits the puncture pin. On the outlet manifold assembly, I want to turn that in an off position. And on the hydraulic pump, I want to make sure that my valve is closed. This is tight all the way, the hydraulic valve. So basically I'm ready to go. I want to connect the heating jacket to my electrical source, and as with all heating jackets, these are numbered 1 through 10, so it's up to you to determine at what temperature number 3 is and number 5 and so forth, and you can mark it ever how you want to. And once the target temperature is reached, your thermostat pilot light will come on. Since this is demonstration purposes only, and since I don't want to heat things up, I'm going to leave this in a non-heated setup. If I were heating, however, I would you initially start with your thermometer in the thermometer well, like so. And typically, we have these thermometers in 2 different lengths. We have a 5-inch length and a 8-inch length. A lot of times I like to use the 5-inch and use a longer one for up top, or you can use one or the other. You don't necessarily have to use both. The next thing you want to do is you want to inspect all O-rings. These are the O-rings around the cell cap, the O-rings on the valve stem connections, the O-rings in the cell. Inside the cell body is an O-ring recessed groove. You want to make sure that there are O-rings in all of these and that your O-ring is in good shape. The O-ring is an elastomer. It is a synthetic rubber, and as such it can deform. You can get flat spotting. We call that drift. And if you have a flat spotted O-ring, or you have an O-ring with a nick in it, it's not going to hold pressure. We recommend you change the O-ring after each test in excess of 300 degrees Fahrenheit. That's just a good rule of thumb to go by. So above 300 degrees, change your O-rings after each test. Additionally, you want to apply a thin coat of grease. Never Seas or Dow Corning high vacuum grease to all of your O-ring surfaces, everywhere, particularly on the cell cap. You also want to apply a thin coat of grease to the threads, because this is a 4,000 psi rated cell, and as such you've got an unbroken metal to metal contact all along the length of this thread, and under elevated temperature and pressure you get a little bit of heat expansion. So if you apply a small amount of grease to these threads initially ahead of time, you'll find it makes disassembly so much more easy later on. So always apply the grease to the threads and to the O-ring seals. The next thing you want to do is you want to tighten the inlet cap using the strap wrench and the spanner wrench. The inlet cap has a no screen, And if we're going to use ceramic disc, the ceramic discs that have a 1/4 of an inch thickness, then we have to use the outlet end of the cell, because the outlet end of this cell has been reamed out an extra 1/4 of an inch to accommodate the thickness of that disc. The outlet end of the cell is marked, and I don't know if you can see it there, but right there it says out. The I don't know if the light will allow that, but that right there says out. On the inlet side, there is nothing. So initially, we want to install the inlet cell cap. And again, the inlet cell cap is bare metal on the inside of the cap, because you're just pressurizing through this. And again, since we're filtering up, the inlet cap is going to end up on the bottom. So in order to attach this, I find it's easier to put the inlet valve stem assembly in place. That way I can hold it a little bit better. You don't have to have this on there, it just makes it easier. And I want to push the cap in so that the O-ring is seated below the top of the cell assembly. And I will turn the camera around and kind of zoom in on this a little bit. The idea here is to get it started, get it seated, and you may be able to make a few turns with the cap without using the spanner wrench, but this spanner wrench has a couple of nipple-like projections here. These fit in the holes in the cell cap. These cell caps, this is the outlet cap, but it has the same thing in these holes here. So the spanner wrench also has a groove for the O-ring, or for the valve stem. So if I put this in place, I can hand hold it, and I can turn it pretty good by using my other hand to keep the cell from turning. But I'm not going to be able to tighten it down completely without using the strap wrench. So this is about as far as I can get as such. So I have to use the strap wrench in order to tighten this down. And I do like so. I use the strap wrench in place, although I think I've got it backwards. Like so. And I want to push against. I use the strap wrench to hold the cell in place, and now I can snug tighten. If I can get out of the way, you can see what I'm doing. I can snug tighten the cap down using the strap wrench to hold the cell in place. So I have installed the inner cap, in the inlet cap into the cell, and I'm going to remove the inlet valve stem for a very good reason, because next I want to install the piston. And if I have this in place and I go to install the piston, I'm pushing against a vacuum, and it makes it very difficult. So if I invert this and I take my floating piston and the T-screw and I screw this in place, and again, these O-ring seals have been, they have grease on them so that they slide easily inside the cell. And I want to push this all the way down so that it comes in contact with the inner side of the inlet cap. And I can push this down a ways, and if I lift up, that lets the air out, and so that facilitates putting the floating piston in place. That's also why it's good not to have the inlet valve stem and quick connect assembly in place whenever I do that. So now we have the inlet cap in place. We have the piston inside the cell. I now want to place this inside the heating jacket. So I will back this out and what I'm going to do, this cell rest plunger here is, when it's in the out position, this allows the cell to go all the way down in the heating jacket. If I push this in, it suspends the cell above the heating jacket so that I can access the cell from the top. I can put my my test solution inside the cell assembly. I can put my filter media over it, and I can attach my outlet cell cap. So I'm going to carefully and gently slide this in place, and hopefully you can see that is held in place by the cell rest plunger, and I've got room up here where I can attach my strap wrench, and I can tighten things down whenever I get ready to do so. So now we're ready to do some serious work. I want to attach the inlet valve stem assembly, and I can do that by just finding the hole in the end of the cap. I will tighten it by hand as far as I can. I want to take my wrench and then gently, but not overly much, tighten that just to find out where tight is, because the next thing I want to do is I want to loosen it. I want to loosen it a good half a turn. So now I have my inlet valve in place, and it is loosened so that I can get pressure inside the pump. I want to turn the pressure relief valve on the hand pump clockwise all the way. Next, I have already done that, and the next thing I want to do is I want to attach the quick connect. And this has to be done very, very carefully. It either goes on easily or it doesn't. But what you're doing is you're moving this part of the female part of the connector. You're moving it back so that you can push this up over the male counterpart. The trick is it has to be all the way up over this groove here. And I will remove the thermometer so maybe you can see it. It has to be all the way up over this groove. It's easy to get it 95% of the way there, but it has to be all the way. And if it doesn't go all the way up, you're not going to get hydraulic pressure into the cell. So I'm going to try pushing this way out, and voila. The trick is to pull down on the sliding part. And that went in fairly reasonably. So now I've got my inlet pressure assembly attached to my inlet valve stem assembly. Again, this is the safety bleeder valve. This is set to pop off at about 4,200 psi. I can put as much as 10,000 psi in with this hand pump, and since that would not be recommended, this prevents me from overpressurizing the cell assembly. I would turn my ball valve thusly, so now I can get hydraulic fluid coming by. And this is my gauge, which tells me how much pressure I've got on the system. The idea here is that you want to allow for heat expansion of your fluid. In conventional filtration testing, you leave an air pocket at the top of the cell for your fluid to expand. You cannot do that in a HTHP permeability plugging apparatus situation. These ceramic discs have to be soaked in base fluid. In this particular case, I have these ceramic discs soaked in water because we're going to test a water-based drilling fluid. If I was testing an oil-based fluid, I would soak them in diesel oil or mineral oil or synthetic oil, whatever the case may be. But you want to soak them for at least 30 minutes. Some companies say overnight. I think most companies do like we're doing. You find yourself a beaker and you just let them sit in that forever. The reason for that is if you hit the ceramic disc with dry air in the pores between the ceramic parts, the mean pore throat diameters tend to get plugged up if there is no liquid in there. The particles in the fluid will prematurely plug the disc, and you'll get an unrealistic amount of plugging. If, however, the ceramic disc is pre-soaked in the base fluid, then you have liquid in there. You get a more realistic flow of your particles and your liquid, and you don't prematurely plug up the disc. And in downhole environment, everything is wet anyway, so that is more indicative of what really is going on, and that's what you're trying to measure with these ceramic discs. If you let, here at the top, if you allow an inch and a half of space, and that's what we're calling for, an inch and a half of fluid expansion on a 500 mil high temp filter press. If I allow that at the top, then I've got an air pocket underneath my pre-soaked disc. As soon as I hit it with pressure, that air pocket is going to void the liquid in my disc. So to avoid that, we fill the cell all the way up and then place the ceramic disc where it's literally almost floating on top of the liquid to prevent voiding the liquid inside the disc. So where does the fluid expansion go? Well, it comes out the bottom. We want to initiate about an inch and a half of hydraulic fluid in the bottom of the cell and push that floating piston up an inch and a half, so that when the heat expansion takes over, that the disc will come back down on inside the cell, and your hydraulic fluid will flow back in to the hand pump. So that is the fluid expansion. It's the hydraulic fluid that expands down to maybe nothing, and not your test fluid that expands in a permeability plugging tester. So what we do, how do we get that? Well, a good way of doing it, in a way that I do it, is I take a trusty OFI rotor and I gently place it on the thread's recess, and then I just look and see. I'm looking at about, it's about 3 1/4 inches across the top of the T-bar. So what I want to do is I want to pump that up until it's about, say, until it reads about 4 1/2. I want to put roughly an inch and a half of space for my fluid to expand. So I'm going to do this without hopefully getting too much in the way of the camera, but I will move this up so hopefully you'll be able to see this. There is no set amount of pump strokes, but you can see it's going up, or hopefully you can see it's going up. And what's happening is the piston is rising inside the cell. And it is just about where I want it to go. Maybe just a little bit more. That should do it. Yeah, perfect. All right, so now I have the 1.5 inch room in the bottom of my filter press cell for my heat expansion of the fluid. The next thing I want to do is I want to close the inlet valve thusly so that everything remains in the cell. I want to remove the T-handle from the piston in the cell And I want to next add my test fluid to the bottom of the O-ring groove. And I will do that in the next segment. But for right now, this is basically the test setup and getting ready to run the permeability plugging test. As I mentioned, the next segment we will use a real world drilling fluids. We will run a real test on the OFI testing equipment permeability plugging tester. So until then, I thank you for your attention.